This is Iran's Shahed-136 combat drone, a weapon that has created significant impact around the world. Now, to understand its importance, let's compare it with other modern weapons. The American Tomahawk cruise missile costs several $1,000,000. Russia's Kh-11 cruise missile also costs around $2 to $3 million. Iran's Fateh-110 missile can range anywhere from about $15,000 to nearly $1 million. And then comes the Shahed-136 drone. It's also an attacking weapon that falls into the broader missile category, but its price is dramatically lower, roughly between $20,000 and $50,000, sometimes even cheaper than a car. This technology has shown the world that modern warfare is not only about advanced weapons, it can also be fought economically. This drone is known as a loitering munition, and it is often called a suicide drone. Before striking its target, the drone performs reconnaissance by circling above the target area. Some targets only appear briefly and then disappear. The moment the drone detects its target, it dives in for the attack, destroying the target and itself at the same time. And when this drone flies through the sky, it produces a sound that resembles a scooter engine. Because of that unique sound, it's often nicknamed the flying scooter. In fact, it actually uses a small two-stroke engine similar to those found in scooters. Now let's take a closer look at how it works. The drone is about 365 meters long, with a delta-shaped wing design and a wingspan of roughly 295 meters. Its total weight is around 220 kilograms, making it relatively large compared to a human. At the front of the drone sits the warhead, which can weigh between 30 and 50 kilograms, depending on the target. At the back, a propeller generates thrust for flight. However, the drone cannot launch by itself. It requires a launcher system. Inside the drone is a two-stroke gasoline engine, imported cheaply from China. The design is inspired by older German engines. Interestingly, during World War II, German aircraft used something called the Jericho trumpet siren on their landing gear. When the aircraft dived at high speed, the propeller-driven siren produced a terrifying sound that created psychological fear among people on the ground. In a similar way, the Shahed drone's engine produces that distinctive buzzing sound. The engine is air-cooled, meaning it doesn't have a traditional cooling system. Instead, the airflow during flight naturally cools the engine. It produces about 50 horsepower, allowing the drone to reach speeds of around 200 kilometers per hour. To maintain stability during flight, the drone uses control fins near the engine at the rear. The wings include flaps that generate lift, keeping the drone airborne. Behind the wings are elevons, which help the drone turn and maneuver. These are controlled by servo motors. At the center of the drone is its onboard computer system, which manages the entire flight. The drone uses a GPS system connected to satellites to determine its position and direction. But if GPS becomes unavailable, the drone can rely on an inertial navigation system, which uses sensors such as gyroscopes and accelerometers to track speed and movement. Some versions may also include an anti-radiation seeker. This sensor detects electromagnetic signals such as those emitted by radar systems. Once the drone detects a radar signal, it can automatically move toward the source. If the radar of an air defense system is destroyed, the defense system is destroyed. The defense system essentially becomes blind. Now the next question is, how is this drone launched? Because it cannot take off on its own, it is mounted on a launcher truck. The drone sits on a launch rail at an inclined angle. Under the drone is a rocket booster. First, the booster ignites and provides the initial thrust required for launch. Once the drone reaches the air, its two-stroke engine starts running. After the engine takes over, the booster detaches from the drone, making it lighter and more efficient. The drone has a range of roughly 2,000 kilometers. But one of its most important features is that it is used in drone swarms. That means these drones rarely fly alone. Instead, dozens or sometimes even more than 100 can be launched at the same time. All of them coordinate with each other. They don't attack the same target. Instead, each drone is assigned a different target. And because they usually fly very close to the ground, they become much harder to detect and intercept. Technologically, modern air defense systems can destroy these drones, but economically intercepting them can be extremely expensive. Most countries design their air defense systems with 3 layers of protection. The first layer includes surface-to-air missile systems such as Israel's Iron Dome or India's Akash air defense system. These systems use radar to detect incoming threats, then launch interceptor missiles to destroy them. However, when large numbers of drones attack at once, some may still slip through the defenses. For example, the Tamir interceptor missile used by Iron Dome costs significantly more than the drone it intercepts. And the Patriot PAC-2 interceptor missile can cost between $2 and $3 million, many times more expensive than the drone itself. Fighter jets can also intercept drones, but that is one of the most expensive methods. Another option is anti-aircraft guns, which use radar to detect targets and then fire at them. But their effective range is only about 5 kilometers. The second layer of defense targets threats such as aircraft, cruise missiles, and medium-range ballistic missiles. Israel uses the David Sling system, while India uses Barak 8. Finally, the third layer focuses on intercepting long-range ballistic missiles, often outside the atmosphere. Israel uses the Arrow 3 system, while India deploys the S-400 system. Understanding drones like the Shahed-136 reveals something important about modern warfare. It's no longer just about technology. It's also about cost, strategy, and economics.